The domain is a way of saying what numbers is it possible for x to be. And by default, x could be any number in the whole world. So that's usually the domain. But when you have a fraction like this, there's a special rule that the bottom of a fraction cannot be 0. So in this case, the domain is going to be any number in the whole world except numbers that would make the bottom equal to 0. So the only thing that would make the bottom equal to 0 here is if x was a -3. -3 plus 3 would equal 0. So x can be any number but -3, and that's what D represents here. You start all the way at -infinity and keep going all the way to +infinity, but there's a gap here at -3, which is not included. That's what the parentheses mean. Trying to convert the number 2 here into a rational expression that has this denominator, what you're going to want to do is multiply the top and the bottom by the same exact expression. When you do that, you don't change the value, you just change the way the expression looks. So 2, the top's 2 and the bottom would just be a 1 if you rewrite that as a rational expression with a top and a bottom. So this is how you would write 2. And then you want to convert that so that the bottom is a plus 6. So you're going to multiply on bottom by a plus 6. And if you multiply on bottom by that, you have to multiply on top by that as well. So then on bottom, you'll just get 1 times a plus 6, which equals a plus 6, which is what you wanted. And on top, distribute. So 2a plus 12. Here we need to subtract two rational expressions and then reduce our answer. Now when you're subtracting, it's just like subtracting fractions, where you have to have the bottom the same, which we do here. And when you have the same bottom, you just subtract the tops. So an example with fractions here, 5/7 minus 3/7, since the bottom's the same, you just subtract the tops. You do 5 minus 3, and the bottom stays put. And so 5/7 minus 3/7, you end up with just 2/7. So with the rational expression here, we have the same bottom, so it's just going to stay put at 4y. And on top, we're going to just subtract, so 6 minus 14y. And you take that and subtract this whole second thing, so we're subtracting 2 minus 10y. And I'm writing it out in steps like this because the most common error students make is when they distribute this subtraction. So you're doing 6 minus 14y, and you're subtracting this whole thing, so you're subtracting 2, and you're also subtracting negative 10y, which ends up being plus 10y, and you subtract the negative 10. Alright, so now reduce. 6 minus 2 leaves you with 4, and negative 14 plus 10 leaves you with negative 4y. So we combined the like terms here, those two, and then negative 14 plus 10. And then on bottom, again, we just had the 4y. So that's what you get after you've done the subtraction, but the problem gave you a hint here that you may need to reduce, and you do need to factor out the top. You can factor out a 4 and get 1 minus y. And on bottom you have a 4 multiplied by y. So these two 4 factors are going to cancel out on top and bottom. And then your final answer, which I'm going to write over here in green, would just be the 1 minus y is all that's on top, and just the y on bottom. Here's a similar problem, but a little more complex, where we're trying to subtract, but now the denominators are not the same to start with. So we have to make them the same before we can subtract. And you're going to want to start by factoring, which I've done that step already. So the x squared minus 49, x minus 7, x plus 7 is what that factors to, the difference of two squares. And then this expression right here would be x plus 7 and x minus 8. So you can FOIL that and see you'd get back to that. So these are not the same. They have one little bit that's the same, but then they have two factors that are different. So to make them exactly the same, here's what we're going to do. This first fraction is missing the x minus 8. Alright, so we're just going to add it in. Multiply here by x minus 8. But you have to do that on top as well as on bottom, or else you're changing the value of the expression. If it's the same on top and bottom, it doesn't change the value any. And over here, we were missing the x minus 7. So we're going to add that in, again on top and bottom. And then the rest of it stays the same. So we add one thing in on top and bottom for both of the expressions, and then they have the same exact bottom. And then now all we need to do is subtract. And I wrote out the subtraction bit here. So 7 times that, you get 7x minus 56. 8 times that, you get 8x minus 56. So do the subtraction, make sure you're subtracting each part. So we're minusing 8x. We're going to have 7x minus 56. And then we minus 8x. But we minus a negative 56. So we end up actually adding that 56 because we minus the negative. And the bottom stays the same. So I'm just going to keep reducing the top here. So 7x minus an 8x, you have a negative x, minus 56 plus 56, that just completely cancels out to 0. So the whole top reduces to just that. And then this will be the bottom, the x minus 7, x plus 7, x minus 8. So for your answer choices, that looks like A, where there's just a negative x as the top, and then the bottom is x minus 7, x plus 7, x minus 8.